Good day to everyone. In this presentation, I will demonstrate my laboratory activity or assignment, which entitled Mini System Integration from Data to Functionality. So the goal of this assignment or activity is to show how two independent software subsystems can communicate and work together using a system integration model, similar to what happens in real-world organization. So let's head down to the concept overview. So in many organizations, different departments use separate systems, databases, and applications. Despite being independent, these systems must be or must still interoperate to support business processes. This laboratory demonstrates that concepts using a simplified setup with two subsystems integrated using the data integration model. So for the system overview, my system is composed of two main components, subsystem A and subsystem B. As you can see, I have named them subsystem A and subsystem B, and also the language I'm using is Python. These two subsystems are developed independently and communicate only through structured data. So let's go here sa subsystem A. So which is the data provider. So this is the data provider, which is the subsystem A. Subsystem A represents a student information system. Similar to an enrollment or registrar system, its main responsibility is to manage student records and export them in a structured format. The subsystem stores student information such as ID, name, course, year, and status. So once the data is prepared, subsystem A generates a JSON file. As you can see, I have import JSON. So this is what it generates, a JSON file called students.json, which serves as the integration point between the two systems. So right now, I will run the subsystem A to show that it will create or generate a JSON file. So as you can see, subsystem A data exported successfully. So now it creates the students.json file. So when I click this, it will automatically be load. So generated at, this is the timestamp, this is the record count, and then in this area, these are the students information. So we have student 1 with the student ID, Juan de la Cruz for the name, course BSIT, year level which is 2 or second year, and then the status is active. What do I mean in status is that he or she is currently enrolled in the school. So same student ID, name Maria Santos, course BSCS or computer science, year level is 1, and then status active. Now we have also an inactive example, and the last is the active one. So this is the generated JSON file which stores all the data that the subsystem A did. So this is where that student.json file was created. So this is the student data provider. So we have the generated at, record count, and students. So we have also a if else, that will prompt if duplicate student ID. It will ignore if there are students who have duplicate student IDs. So this is the subsystem A. Now, the integration model used in this project or laboratory exercise is data integration. In this model, systems exchange information through data files or structured outputs rather than direct function calls or shared user interface. So, subsystem B does not access subsystem A's internal logic. No, so dili niya ni so it will not directly no it will not directly access the subsystem A or A's internal logic. So here this code will not be directly be accessed by the subsystem B because they are not connected with one another. So it only provides or it only reads the data that subsystem A provides. So since subsystem A provides this data that is stored in JSON file, now we'll try to run the subsystem B. So okay, let's go back. So since subsystem A generated the student.json file, then now subsystem B will acquire this data. Subsystem B will now be using this data in order for it to be generated here in the GUI. So it loads the student data and display it in a table format for easy viewing. So this is what it looks like. So we have a table format now. To simulate a real-world system requirement, subsystem B includes several features. A search function to find student by name, a status filter to display active or inactive students. Next is a refresh button or apply button. So when you click this, it will just generate the active, and then next is the inactive, and then when you apply, it will just automatically refresh or load the data. And an export feature that allows user to save the displayed data as a CSV file. So these features demonstrates how consumer systems often add value by processing and presenting data in a user-friendly manner or way. So the integration flow of this is very straightforward. Subsystem A generates the student data and export it as a JSON file. So this is it. Subsystem B then reads this file, transform the data for presentation, and display it to the user, which is through a graphical user interface. So there is no shared code or database between the system, ensuring loose coupling. Integration challenges. During the integration process, several potential challenges were identified. This includes data format mismatches, also includes changes in data structures, and the need for data transformation before presentation. For example, if subsystem A changes a field name or remove an attribute, subsystem B may fail unless it is updated accordingly. These challenges are similar to a real-world ETL and system integration issues. So now let's go down to the real-world application. This project reflects, or this laboratory reflects, real-world integration scenarios such as enrollment system, feeding report or reporting dashboards, HR databases supplying payroll systems, financial systems exporting transactions data for analysis. In all these cases, data integration enables independent systems to work together effectively. So in conclusion, this laboratory exercise or activity demonstrates how system integration models, specifically data integration, can be applied even in small-scale systems. By separating responsibilities between subsystems and integrating them through structured data, we achieve flexibility, scalability, and maintainability. And I think that's all for the uh, showcase of this subsystem integration. I hope you've learned something and thank you for watching. May God bless us all.